Welcome to the third part of this Fit2D tutorial. In this part, we will be explaining how to create composite maps. Composite maps is a way to visualize the data collected from an area scan. Say this is our sample. To perform an area scan, we select a point and we collect the diffraction pattern for this point. Then we move a set distance in X and collect another diffraction pattern and another one and so on. And then we set a, um, a set distance in Y to collect diffraction patterns as such. Then we will end up with a area scan having multiple diffraction patterns in X and multiple diffraction patterns in Y. It is important to note, and this information can be acquired from the experimental log that usually is kept when creating these area scans. It's important to note the number of diffraction patterns in X and the number of diffraction patterns in Y. So the number of diffraction patterns are the number of columns in X, and then the number of diffraction pattern in Y are the number of rows. Now we will open Fit2D. As usual, we click accept and then we select the number of pixels of our detector. In my case, it's 3056 by 3056. This number is different in different detectors. Then when we click OK, we will be directed to the main menu. In this menu, we will select the file series option. Then we will be directed to another menu. In this menu, we need to select the composite option. Then the program will ask us to select the first file in the series. So I will go ahead and navigate to my data file folder. And here are my data. So I select the first file in my data, and then it will show me the diffraction pattern of the first file, and it will ask if the file is okay. The file looks fine, the diffraction pattern looks fine, so I click yes. This menu will appear. We click exit. Then it will ask us to select the last input file in the series. So we go to the last file. In my case, it's the very last file in this folder. So I just click this button, which will take me to the bottom of the page. And I just select it. Here it will ask about the file increments. So I would not like this program to skip any diffraction patterns. So I would like an increments of 1. So it will include all diffraction patterns. If we select 2 or 3, it will skip 2 or 3 diffraction patterns, resulting in a smaller composite map. In my case, and my recommendation is to leave this at 1 and click OK. Here we get to the menu which says Control of Composite Image Display Parameters. In here, make sure that you uncheck. So this should be this should be no. We don't want to subtract background, and we don't want to select a region of interest. So we click the ROI to change this into no. Now, if you remember, I mentioned that we need to note the number of columns and the number of rows. So how many diffraction patterns in X and how many in Y. So in this option here, it's asking us for a number of images per row. So this is the number of columns. In my case, this is 73. And then the final two options, we leave them at 8. We don't change these. And then we just click OK. Then it will ask if we want to destroy and create bigger program arrays. Yes, we would like to do that. So click yes. Now we wait for the program to create the composite image. This takes, depending on your data, about 3 to 5 minutes. We will be greeted with this image of our composite. If you are having trouble viewing this composite map, if it's not as clear as the one you're seeing here, you can simply just click on the intensity and then go to weak peaks. This should um, adjust the intensity so you will be able to see your diffraction patterns. Also, what we need to do now is also, while we are clicking in the intensity, oh, I've changed something there, so I'll go back to weak peaks. Also, in the intensity scaling, before exiting, we need to note the user maximum. So in our case, this is 70, and you can round it up. So this is 70, note this number. Click OK, and then we need to save this composite map. So we click on Exit to go to the previous menu, and then we go to Output. Click Output, then we will have this file format menu. We click on TIFF 8-bit. TIFF 8-bit. We click on that, and then it will ask us, do you want to use the nodata.tiff? I recommend that we always click no, because we want to set or select the folder we would like to save this image at. So we click on no. Then it will ask us to select the output file. So where do we want to save this composite map? In my case, I would like to save it in the desktop, and I would like to also change the name. So I can change the name from here, make sure that the tiff is always there, .tiff. So let's say test. So it will save it in the desktop as test.tiff. Click OK, or in my case, I just pressed enter. It will take me to this menu which asking for the lower limit of range. This should always be 0, so leave this at 0. Click OK. And here it will ask us at of the upper limit of the range. So remember the number we noted at the user maximum. As you can see here, this is totally off. It's 10,000. This should be 70. So this should be 70. We click OK, and then we wait for a couple of minutes until the composite map is created. Once we get to this back to this menu, and we can see this diffraction, this composite map on Fit2D, that means the process was successful. We go in our file or the folder in desktop, and we select the composite map, and here it is. So now we've created a composite map with 73 columns, ready for the next stage. Now, from this composite map, we can see individual diffraction patterns stacked next to each other according to the area scan we selected. As you can see here, we don't have any diffraction patterns, so this is probably air. And then as we move towards the into the sample, we can see diffraction patterns with reflections forming. So this is a great way to identify which diffraction patterns are within the samples and which diffraction patterns are um, in air. To be able to identify which diffraction pattern is which, or to kind of link the file number to the diffraction pattern, we usually copy this diffraction pattern into PowerPoint. Here we have it in PowerPoint. Then we go to Excel, and then we select a blank workbook. Then we need to construct this area in numbers. So what I mean is we select, in the first cell here, we input 1 and then 2, and then we drag it. So it has to be 1 and 2, then drag it to 73. Because we have 73 columns. So this is our 73 columns. Again, we go here, we type in the number following the last number in the columns, and then 75, here we go, and then the same thing, we just drag it. Here we have up to 1046. Now we select all of these cells, and we go up to the number of diffraction patterns that we have. So now here we have the number of diffraction patterns according to the way we've scanned our sample. So file number 1, 2, 3, 4, 5, 6, and then up to the last diffraction pattern. Then what we do is we select all of these cells again, and then copy it. So Control C. Once this is copied, we go back to our PowerPoint where we have our image at, our spreadsheet here. Here's our cells from our spreadsheet pasted there. The first thing to do is just to make sure that we remove the shading, so you can see the diffraction patterns from behind the spreadsheet. So we go into shade, so we go to table design, then shading, and no fill. So here, as you can see, we don't have any background. Then if we have our columns and rows set correctly, we just need to resize the spreadsheet to overlay our composite map, just as such. Here we are. We have our spreadsheet laid perfectly onto our diffraction patterns. Then we zoom in. This is a very big file, so if you expect it to be quite slow in movement. So we select one of the file, one of the numbers we just selected, and then we click Control A. And then we can increase the size of these numbers, so we can easily see them. To do that, we just go to Home, and then we just increase the file size, let's say to 10 in our case. Let's see how that looks. Oh, that's too big. Maybe to 8. Still big, so maybe we'll do it a little bit drastically smaller. Yeah, that would be perfect. So you are able to see the numbers are not too small, so they're very easy to identify. So now we have our diffraction patterns in our composite map numbered according to the file number. And this is a quite important if we would like to identify which diffraction patterns are air and which are actual crystalline sample. So um, if we go to the edge here, you can see that diffraction pattern number 1534 is air. 1535 is also is air, and then the sample or the crystalline substance start at um, file number 1536. This is a very nice way of identifying the data within our composite map. And this brings us to the end of part 3 of Fit2D tutorial. I hope this was helpful. Thank you for listening and have a great day.